Hi students, let's look at this question here, which is on integration. Let's see how we can do this proficiently. So we are given the integral in is given by this expression here, okay, for where n is a natural number. So show that I0 is this guy. Okay, now I think the first thing to do is to actually plot the graph without the modulus, of course. But if you want to plot in more modulus, it would do as well. So this is the graph we're looking at using our GC. Okay, so if I were to plot this in GC without the modulus, okay, just be mindful. So this case here, it looks something like that. Okay, we know that so if we zoom standard, you will look something at the bottom. You zoom to this region here. Okay, now we take the modulus, the negative region will just flip up. That's the idea, right? So I'm just gonna just zoom box to this area. I'm gonna see how it looks like here. Okay, it should be up and down. So the graph will look something like that. It's like diminishing. Okay, so but the idea is very simple. You want to flip it up, right? So when you take the modulus graph, it looks something like that. It comes down, then this region will just disappear. So whatever is negative is being flipped up. So the modulus graph will look something like that. Okay, the original graph will be the dotted side there. So the reason why I draw this out is because so that we understand this. Essentially what is going to be causing it to be 0 is a sign. So we know that sin x is 0 when x is 0 pi, a multiple of pi, right? So I know that this graph will look like 0, here is 0, this is pi, this is 2 pi, this is 3 pi, and so on. So these are the graph that we're looking at. Okay, so now what we want, okay, so e minus x, so I forgot to mention, because this guy is always positive, all right? So we could rewrite this as minus x sine x. So they are similar. These two are actually equivalent, right? They are the same function there. So now what we want is I0. So we're just gonna write I0. I0 will be from 0 to pi. You can see that. So I0, because when n is 0, n is equals to n+1 n pi e minus x sine x dx. So when n is 0, we rewrite this to I0 1 0 e minus x. So from 0 to 1 pi, so this is pi here, pi. For 0 to pi, we are taking the positive, it wasn't flipped up, right? Because you're taking the original equation. So this equation here is the positive one, which is, remember when it comes to modulus, you can have a positive function and negative. So this is a positive one that is not being flipped up. So this guy here, okay. So then the negative one will be this guy here. So if I were to write y equals to minus e minus x sine x, will be this guy, and this guy. Okay, that one that's being flipped up. So here, what we get is sine x dx. Okay, so 0 to pi. So I could just rewrite this 0 pi e minus x sine x. So I'm gonna just use by parts to do this. We're gonna find how to do this by parts first. So this is a typical infinite series. So I'm going to do a indefinite integral here. Okay, if not, I'm gonna keep writing. It's gonna be very cumbersome. So you can let either one be your u. I'm gonna let this be my u. This is my dv dx, right? So u is equals to sine x, and dv dx is equals to minus e minus x. So du dx will just be cosine x, right? V will just be minus x over negative 1. So what you're gonna do is just uv cosine x minus of v du uv, so sine x. Then this will be v du dx, which is minus x cosine x here. Okay, here same thing. I'm gonna let this be my u1. This is my dv dx. Obviously without the negative. So let me just rewrite this down. There you go. So u1 will be cosine x, then dv dx will be minus x. du1 dx will just be negative sine x. Then v will be negative e minus x. Then do another by parts. From here, what we get is minus negative x sine x. Just try and bracket it. So plus u1 times so it's negative e minus x cosine x minus of e minus x sine x. This will be positive both sides. Okay. Now just take note, once you reach here, you here will be equals to this one. So this is if you're a part of a problem and part of a solution, just don't continue on. If you continue on, you essentially will just go on forever. You will not stop, right? Because you get the same answer there. So what we get is e minus x dx is equals to minus e. Oh, this is minus x. Okay, minus x. So once done, you know that this will be equal to this guy. So I rewrite this guy here. This is this and this is this. Okay, so that's his own solution. So you just bring it over, just like algebra. Okay, you bring this over to the other side with 2 minus x sine x dx equals to minus e minus x sine x plus cosine x. Then e minus x sine x dx minus e minus x over 2 sine x plus cosine x. Okay, plus c. But I don't really need the c, but you can just leave the c there, no issue. So this guy is an entire side quest for this. So then I'm gonna just put 0i here. So you put it in. So using this formula will be minus e minus x over 2 sine x plus cosine x. You don't need the arbitrary constant because when you substitute 0 pi, you just cancel off each other. So this is minus e minus pi over 2. Sine pi is 0. Cosine pi is -1. Then minus of minus e minus 0 over 2. Sine 0 is 0. Cosine 0 is 1. Okay. So here we get the answer. Just rearrange. So it's half 1 plus e minus pi. Shown. Great. So let's look at the second part. This is by letting y equals to x minus n pi, show that in is equals to this. Okay, so actually what we can do, this is just a translation actually. So this is just translation, but this is substitution, right? So we can just substitute this as y equals to x minus n pi. Come, let's do that. I think the first thing to do is to write down what's in first. In would be what was given just now, which is n plus 1 pi, and alpha, which is n pi, right? E minus x sine x dx. Okay, so what we now need to do is just differentiate dy dx will just be 1. This is a constant, right? So you just let dy dx is 1. So essentially what you get is dy equals to dx. Okay, so this is dy. So what we're going to do is just replace all the value into y, right? For example, you have basically you know that x is equals to y plus n pi. So I'm going to do that. So this case here will be e minus y plus n pi. Then this will be sine y plus n pi. This will be careful about the modulus. So dy equals to dx, so we can just replace this. Now be careful is that this is x equals to this, x equals to this. So we need to change to y, right? So when x is equals to n plus 1 pi, okay, we will get our y here. So y will be n plus 1. The x, we just replace it in. Okay, that will be equals to pi. Okay, so this will be pi on top. Change the boundary. Important. So when x is equals to n pi, y is equals to n pi minus n pi, which is actually just 0. So this is 0. Okay, this is basically just a translation. Okay, then we rewrite everything. Then we'll just see what we'll get. So this is 0 to pi, which is good. E minus y dot with e minus n pi. This is sine y plus n pi. Actually, we could just n pi. We can just use sine a sine b, the formula. Okay, so I'll just expand this guy. Sine a cosine b plus cosine a sine b. Okay, so this a multiple of n pi is 0. This is 0. You have to know that this is 0. So 0 plus cosine y is 0. So cosine n pi multiple of pi will depend whether it will be negative or positive. It doesn't matter. So this is either -1 or +1. Right? Key in calculator, you see multiple of pi or cosine. You'll be just key in calculator, like the table of values here. So you have let's say cosine n pi. Okay, you go to table, you have 1 and -1. So it really doesn't matter because when we mod it, you'll be happy. So the constant, we can bring it out. This is a constant. Okay, you bring out of integral e minus n pi 0 to pi e minus y sine y cosine m pi. This is 0, right? So no, don't care. So this is plus. Modulus plus minus 1 will just be 1. So what is left behind, very conveniently, is en pi. 0 pi e minus y sine y dy. You see that this is from 1. This is from A. From A. So this is your I0. So this is E. Is minus n pi. I0. Yay. Done. Okay. Interesting question here. Let's look at part C. C is an interesting one. So hence determine the exact value of this guy here. Okay. So let's try and do this. So this is important. What do you mean by 0 to infinity? Look back at the graph. Actually, what you want is 0 to infinity is the sum of this area here. 1, 2. So like this is I0, this is I1, then this is I2, and so on. You have to just write it down. Understanding this is I0 because then I1, I2. From graph, we know that this is 0 to pi e minus x sine x. Okay, maybe I'll let this be this. Let fx be the function there. Then we just be pi to 2 pi dx. Then just be from 2 pi to 3 pi fx dx, and so on, right? To infinity. That's all you want. So essentially, this case here, this is I0 plus I1 plus I2, then plus I3, all the way to infinity because you keep going on forever. Then you just use the formula from this guy here. So EIN. So we know that IN E minus M pi is equal to I naught. Okay. So we have when is 0, I0 is E. So obviously I0 is I0. E1, if you put 1 inside with E minus pi I naught. Okay. Plus E. Just use this formula here. So it's I2, you just sub 2 inside. So it's E minus 2 pi I naught plus E minus 3 pi I naught plus E minus 4 pi I naught. Going forever. So then the I naught, just bring it out. Then you get, I think you get a GP here. 1 plus E minus pi plus E minus 2 pi E minus 3 pi. Pretty is a very elegant question here. Okay, then you get, this is the R is equals to minus E minus pi. Under R and so on. So that go, this will just be sum to infinity. Okay, which is 1 over 1 A over 1 plus 1 minus R. Okay. So that this case will be A, which is 1 over 1 minus R, which is E minus pi. Okay, that's it. So we're just gonna sum this up. So from here, we know also from the first part, from A, I naught is equals to half 1 plus E minus pi. Right. So just substitute this in half 1 plus E minus pi. Okay, you can just leave it like that, or we could just simplify it later. So this is 1 plus E minus pi. So you just manipulate this. This will be 1 E pi. 1 plus 1 over E pi. So you could just multiply by E pi. E pi, just to make it look good. You can just leave it like that. It's not an issue. Then you will get E pi plus 1 to E pi. So, something is wrong. This is minus. Sorry. It's minus. Okay. So that's how I do this question proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.